Okay, welcome to today's lesson that we probably will not finish in class. So you are still responsible for all of the material, so watch the video, pause it where necessary. Like here, try the warm-up on your own. Look for the pattern in the numerator and the denominator to create the nth term. The first term is 2 in the denominator, the second term is 3, third term is 4. So it looks like n plus 1. Up top, it looks like all of those things, but doubled. What is the limit of the sequence is asking. The limit as n goes to infinity of this term. And as we did at the beginning of the year, multiplying by 1 over n over 1 over n, distributing that out, we get the limit of that sequence, the infinite term. Once we finally get to the end of infinity, which yes is impossible, we would get to 2. So that's the limit of this sequence. What's coming up? We're going to do summation notation and the sum of geometric series tomorrow. Wednesday is a review of all the concepts. Thursday is a little bit more of the review and introduction to the group work. Friday is the group work. Tuesday, you're going to present those solutions and any last minute questions, and then there is the test on Wednesday. Here are the answers to the homework. Check your work. Pause if you need. Summation notation. A series is a sequence with all the things added together. So if my sequence is 1, 3, 5, 7, the series is 1 plus 3 plus 5 plus 7. The shorthand of writing all of these things added up is this sigma. And here's my index, K, J, I, and they use lots of those letters. And you go up by one position at a time. It goes 1, 2, 3, 4, or 0, 1, 2, 3, till you hit this ending number. And it's better to look at it like this. How do I generate this list? Well, when K is 1, put in K, 1 for K, and that's 3 times 1 is 3. This sigma means add, so I'm going to put in a plus. Did my index, does 1 equal 5? No, so you need to keep going. Now when K is 2, 3 times 2, does 2 equal that top number of 5? No, keep going, kick it up one more. K is 3, and keep going until we have 4. 3 times 4 is 12. Does 4 equal 5? No, go one more time, 3 times 5. And we get, this is our thing expanded. And then evaluated means add them all up, and that's 45. On this, expand, starting this one at 5, go up till you hit 8, and then add the things together. Here, starting at 0, plug in and go. Pause if you need to. Here, the sum of those 4 terms is 174. This one, the sum of these 7 terms is positive 1. These go to infinity. Sometimes we can add things up to infinity and get a single number. So try these and see what you get. First one, every term was 0. Adding 0 over and over again will still get you 0. This one, you guys recognize the pattern of 0.3 repeating is 1/3. Tomorrow we will go over exactly how to find that 1/3 analytically. Okay, sometimes you're going to be given a list, a sequence, a series that is, and you need to create the sigma notation. So first thing, what kind of pattern do we have? It's geometric. I'm multiplying by 3 each time. My first term is 1. So to find any term in the list, first term times that ratio to the n minus 1. Then putting it into the sigma, starting at 1, we went 4 terms, and that's my a sub n. You could write it in this pink one up here or the blue one there, because the difference is this one said start at 1, this one said start at 0. You will still get the same list. These, to write the sum notation, you need to go through the trouble to find the ending term. So create your a sub n pattern. When does a sub n hit that last term? Pause the video and give it a try. First term is 2. The arithmetic difference that we're adding each time is 5. This is our a sub n term. You could use any one of these in this argument. If we started the list at 1, where is what n value gives me 32 at the end is 7. This one over here, you needed to just recognize the pattern. It's not arithmetic or geometric. It is a cubic, and it doesn't end, so that top thing is infinity. Here, if you had to sum up the numbers 1 to 999, we aren't expecting you to do it by hand. We are expecting you to see a pattern. If you add the first and the last term, it's 1,000. If you take one step in here and one step back on the other end, it's still 1,000. And it's going to keep going that way. So it seems like we need to find out how many pairs of numbers we have. Because it looks like if I add the first term and the last term and find out how many pairs, that's what the sum of those first several numbers are going to be. So find your a sub n, find your general term, which is the first term plus the common difference times n minus 1. How many steps? Cleaning that up, it's just a sub n equals n. So there's 999 terms in this list. So to add them up, first one plus last one divided by the number of pairs is 999 divided by 2. And I get that sum. Try this one. And there's the formula written differently. And there's the sum of the first 30 terms that fit this arithmetic pattern. Okay, pause the video and try these. Generate the a sub n term. Common difference was 4. It goes on forever in that pattern. Sum of the first 10, well, the 10th term calculated is 38. 2 plus the last term over 2 times 10. The number of terms divided by 2, that's how many pairs we had. This one is just adding a half each time. First 10 terms comes out to 52.5. Okay, these are finite sequences. Generate the list, maybe the first 2 or 3 terms and then the last one, and then use the arithmetic summation. Homework is to do problems 1 to 12 on page 749, which is right here.